Hi everybody, this is a simple math channel. In this video we'll talk about what signs trigonometric functions can take depending on the angle. Let's draw a coordinate plane. Let's note the single segments. We also note exactly the same single segments on the opposite sides of the axis, not only in positive sides but in negative sides also. Okay, it will be 1, 1, minus 1 and minus 1. We got 4 points that are at an equal distance from the origin of the coordinate plane. This will be origin, 0 or O. And let's draw a circle through these points. Approximately, of course. Okay, here will be circle. The coordinate lines divide the entire plane and our circle into 4 parts. 1, 2, 3, 4. And each of the parts is called a quadrant or a quarter and is numbered in the following sequence. The first quarter is at the top right. The second quarter is at the top left. The third quarter is at the bottom left. And the fourth quarter is at the bottom right. The radius of our circle, as in previous times, will be equal to 1, because you see, every time our circle goes through the points of 1. And this will be radius. And this will be equal to 1. Let's consider the x-axis. At some angle alpha less than 90 degrees, we can choose any angle less than 90 degrees. We will construct the radius at the circle of the circle. Let's draw the perpendicular from the point of connection of the radius and the circle to the x-axis. Here will be point of connection, and let's draw perpendicular. What can we say about the resulting triangle? We lowered the perpendicular, which means that this angle is 90 degrees. This angle is 90 degrees to it, and we will construct the radius of the circle. And our triangle is right angled. In a right triangle, opposite the 90-degree angle lies the hypotenuse, which in our case is also the radius of the circle. This will be the radius, should be the radius, and it's equal to 1. So the hypotenuse is equal to 1 in our right angle triangle. Consider the angle between the hypotenuse and the x-axis. This will be x-axis, this will be y-axis. The sine of this angle just the ratio of the opposite leg to the hypotenuse. Sine of alpha will be the ratio between this and hypotenuse. And what's this? This is just value of y coordinate. Some coordinate we don't know, but it's nothing for us. Some y coordinate, and this will be length of this coordinate. And we can say, let's do it, let's name it y small and here x small. This means that the sinus of angle alpha equal to a ratio between this value y and hypotenuse 1, which equals to 1, and this means that this is just y coordinate. Of course we don't know what's the value of this coordinate, but we shouldn't think about it now. The cosine of our angle will be equal to the ratio of the adjacent leg to the hypotenuse. This is simply the length of the adjacent leg. For example, cosine alpha will be the same cosine this value, which we know x. We don't know what value of x we have, but we don't mind. A ratio between x and 1, and this equal to just x. It should be noted that we considered an arbitrary angle less than 90 degrees or half pi and greater than 0 degrees. You can notice that in the first quarter, no matter what angle alpha we set, we can draw it like this or like this, it doesn't matter. The sine of the angle will simply be the value along the y-axis, and the cosine of the angle will be the value along the x-axis. Here I want to draw attention to what many overlook, try to teach, and can forget at the most inopportune moment. There is almost nothing to learn, there is logic everywhere. Since in the first quarter we have values on both the x-axis and the y-axis are always positive, because here we goes to the positive values and here we goes to the positive values always, then the values of the sines of any angle from 0 to 90 degrees, any angle, will always be positive or equal to 0. This means that in the first quarter, let's draw it. For the first quarter, sinus of every angle of alpha will be positive or equal to 0 if we consider angle equal to 0. For the cosine alpha will be the same situation, equal to 0 or more than 0, because sinus alpha, this is just only y, and in first quarter it should be positive always, and for cosine alpha this is just x, and in first quarter this is always positive. What will be in the second quarter? Okay, in the second quarter situation is the same. Sinus alpha will be y, cosinus alpha will be x, but in the second quarter yx will be the same, positive. You see, here positive, and here will be positive everywhere, no matter which angle we should draw. And this means that the sinus alpha also should be more or equal to 0 in the second quarter. But for cosine alpha, there is another situation, because here it's already negative values. Here we go to the negative values, and here everywhere x will be less than 0, and this means that the cosine angle of alpha will be less or equal to 0 in the second quarter. In the third quarter, here both values in x-axis or y-axis are negative, because we go to the negative values here and here to the negative values, and this means that the sinus of angle of alpha should be less or equal to 0, and the cosine of angle of alpha should be less or equal to 0. In the fourth quarter, the situation is sinus of angle alpha should be less or equal to 0, because sinus, this is y, and yx and yx here negative. Cosinus of angle alpha more or equal to 0, because axis x here positive, and we obtain these values. What we can say about tangent and cotangent? Okay, in first quarter everything is simple. Tangent alpha, this is the ratio between sinus alpha and cosinus alpha, and both sinus alpha and cosinus alpha more greater or equal to 0, and this means that the tangent alpha should be more or equal to 0, because if we divide one positive value to the another positive value, we obtain positive value. For cotangent of alpha, the same situation, because cotangent is cosinus alpha divided by sinus alpha. This means that cotangent alpha also more or equal to 0. For the second quarter, we have situation that the sinus alpha more or equal to 0, but cosinus alpha less or equal to 0. Positive value we divided by negative value, or for cotangent negative value we divided by positive value. This means that we obtain negative value, and we can say that for second quarter we obtain that the tangent of alpha less or equal to 0, cotangent alpha also less or equal to 0. For the third quarter, here we have negative value and here we have negative value. One negative value we divided by another negative value and we should get positive value. And tangent of alpha in third quarter will be equal or more than 0. And for cotangent of alpha it will be the same situation. And finally, for fourth quarter, for this quarter, we have one value less than or equal to 0 and another value more or equal to 0. This means that negative we divided by positive and we should obtain negative or reciprocal, no matter. This means that tangent alpha should be less or equal to 0 and cotangent alpha less or equal to 0. That's all. There is no magic, just logic. Thank you.